Alright guys, so the point of this hopefully pretty short video is to talk to you about the comparison test. So before we get into what the comparison test actually is, I want to ask a question. I'm going to give you two things and I'm going to ask you which of these is bigger. Is it going to be the sum of 1 over n squared from 1 to infinity, or the sum from 1 to infinity of 1 over n squared plus 1? We'll think about that for a minute. And then hopefully the conclusion you came to is that 1 over n squared is bigger. Right? Because if you plug in a number, like say you plug in n equals 3, this is 1/9. If you plug in n equals 3 here, this is 1/10, which is a smaller fraction. And the same is true for anything, right? You plug in 1 is bigger than 1/2. You plug in 10, 1 over 100 is bigger than 1 over 101. That's just how fractions work. So the idea here is that 1 over n squared, like we know that this series converges. It's a p-series. But if this series is smaller than something that converges, shouldn't it converge as well? And you can prove that by the limit comparison test, but the more traditional comparison test gives us a solid way to do this. So what the comparison test tells us is this, is if you have the series a sub n and the series b sub n, if both of these are series that have just positive terms, then there are kind of two different cases of the comparison test, and we'll count one of both of them. So if your series a sub n is smaller than b sub n, for all values past some point, so maybe the first three numbers are different, but everything from 4 on is the same. So if a sub n is always smaller than or equal to b sub n for all n values plus some point, then we know that if the series b sub n converges, then so does the series of a sub n. Okay, so this is saying if b sub n converges, meaning it adds to a number, then if you have something that's even smaller than that, like your a sub n is smaller, then this will also add to a number, right? Because if it's smaller, how could it go to infinity? It's got to be just going to a number that's just probably a little smaller than the b sub n series. So the other side of this coin tells you that if you have some series that is bigger than b sub n, and again, for all values past some point, meaning everything past n equals 1, everything past n equals 5, whatever, that's not super important. But if a sub n is bigger than or equal to b sub n, if your series b sub n diverges, then so does the series a sub n. So this hopefully logically makes sense, because this is telling you that, okay, if b sub n diverges, meaning that it sums to infinity, then if you are bigger, if you're bigger than something that sums to infinity, well, obviously you will also sum to infinity. So that's kind of what the comparison test tells you. I'm going to be honest, it's not very often that you're going to look at a series and say, oh, I'm going to use the comparison test on this. Mostly it's just something where you want to understand the intuition behind it. That if you have something that goes to infinity and you have something bigger, it also goes to infinity. If you have something that adds to a number and then something smaller, then that also is going to sum to some kind of number. Okay, so one of the useful facts, though, deals with ln. So one of the things you may or not remember is that the natural log of n is smaller than n for all values of n. And you can see this graphically, right? If you graph the function y equals x, we know what that looks like. And if you graph the function y equals ln of x, it looks like that. It is always below that. So because the natural log of n is less than n, that means that 1 over the natural log of n is something bigger than 1 over n. Right? If you have something that's smaller, if you flip the fraction, then it's bigger, right? 3 is smaller than 4. So 1/4 is smaller than 1/3. Okay, so this is useful because, so this shows that because we know the series 1 over n diverges, and we know that because it's the p-series, the harmonic series, or whatever, that means that the series of 1 over ln of n, which is bigger than the series of 1 over n, will also diverge. And that's something that's very difficult to show using a p-series, an integral. It's not geometric. Even the ratio test doesn't really help you with that. So that's just an example kind of what that's going to look like. Okay, so that's what's going on there. Let me go ahead also and just talk about kind of one more quick thing with this. The opposite. The opposite of this doesn't work. So the opposite of comparison test doesn't work. And here's what I mean by that. Is suppose I tell you that A sub n is bigger than B sub n, and I tell you that the series of B sub n converges, we can't really say anything about the series of A sub n using the comparison test. And here's the idea, right, is that if I tell you that B sub n converges, that's basically saying, okay, this B sub n, we sum this together, this is equal to 10, or whatever it converges to, it doesn't matter. If you're bigger than that, like, we don't know how much bigger. So it might be a little bigger and just sum to 11 and still converge, but it also might be a lot bigger and sum to infinity, meaning you might diverge. So if you're bigger than something that converges, you can't really tell anything. And similarly, if you're smaller than something that diverges, that doesn't really help either. Because, if A sub n were to go to infinity and B sub n smaller, well, maybe it's smaller but still goes to infinity just a little slower. Or maybe it actually just sums to 2. So if you're going in the other direction, the comparison test doesn't really help. But if you have a series that converges and you have a smaller series, it also converges. If you have a series that diverges and you have a bigger series, it will also diverge. That's the intuition behind the comparison test. Okay, and again, this is something that's more useful to know qualitatively what's going on than to look at a series and say, we'll use comparison tests on this. Okay, thanks for watching, guys. Bring me any questions you have on this to class, and we'll kind of put everything together and do some practicing. Thanks for watching.